And for our final problem, you should really pay attention because it are tough and it has a restricted domain, which is something different than before.
Thanks a lot, Alan. We'll talk to you later.
Sure thing.
Okay, so if we look at this problem, you'll notice there's again, a cosine and sine. So I am going to look for some kind of connection. And that connection, again, comes through the Pythagorean identity, which we've seen happen quite a bit. So if you take a look at this one, you'll notice that I will begin on a restricted domain. I'm not going to need that 2n or that 2 pi n. I'm just looking for the values that will make this true from 0 to 2 pi. Now notice the 2 pi has a parenthesis. This parenthesis means up to 2 pi, but it doesn't include. So it's not including 2 pi. If we take a look at this then, I am going to first look at factoring. So I'm going to look at this side, figuring that's what I want to attack. If I take out a negative 4, I am then left with 1 plus sine squared x, rather a negative sine squared x. And here's my identity, right there. I'll change that to cosine squared x with a multiplier of negative 4, and I will bring this to the other side. Now on the other side, you'll notice I don't have this in descending order, so I will change this to a negative 9 cosine x plus 2. So again, I'm going to bring my right-hand side to the left-hand side because I want it positive. So I'll be adding this 4 cosine squared x to the other side, leaving me with 4 cosine squared x minus 9 cosine x plus 2, and that will all be set equal to 0. Again, it's a case of factoring, and normally what we see is we see a case where we could relook at this as a 4x squared minus 9x plus 2, and that would happen again if I let this time cosine x equal x. And we'll have our choices, a 2x and a 2x, or we'll have a choice of 4x and x. I see to get to 2, I'll need 2 negatives in either one, and then I need a 2 and a 1. The one that will work out for me then would be a let's see here, need a 9, so a minus 1 and a minus 2 here. So I'll use my 4x, which means over here I'm going to have a 4 cosine x minus 1 times a cosine x minus 2 if I revert back to every x equaling cosine x. Solving these equations by setting them each equal to 0 yields the following 2 mini equations, mini problems. So I have cosine x equals 2, which at this point we know, again, is no solution. Why? Well, hopefully you answered it for yourself, because 2 is not in the range of cosine x. 2 is not in the range of cosine x. This one, however, we end up with a cosine x. We'll bring the 1 to the other side, giving me a value of 1. Dividing by the 4 will give me cosine x equals 1/4. Now this is not in our trig chart, so we'll need to use our inverse or arc cosine value by working this arc cosine value of cosine x. That undoes cosine x, giving me just x. And what I do on one side, of course, I'm going to keep the equation balanced by doing it to the other side. So subtracting 1 here will give, taking the cosine to the -1 will give me the following value on our calculator. 1.31812 as an estimate. Now, you have to remember we are looking for values, and our values are on the interval 0 to 2 pi. And in our unit circle, we found out that this happens for a positive value of cosine both in the first quadrant and in the second quadrant. So those are where my two values will be. I already have the 1.31812 for the first quadrant. So to get this value, I need to take 2 pi and subtract that 1.31812. Now, if I quickly put that into the calculator, which just give me a moment here, take my 2 pi, subtract 1.31812 as my estimate, I find out that I obtained the value of 4.965. So there's my two approximations, and in fact I am done because I am limited or restricted by this domain value there. So I hope you find that helpful, and good luck with your test prep.